Okay, so now we will move on to the .load file, which provides surface load information. Now, it should be mentioned to start with that each airfoil row will have its own airfoil load file. And now, to allow these files to be properly tracked in the output, the case folder, the system automatically appends O1 to the case name and O2 for the second row and so forth. So in the case output file, you will see the case name followed by a -O1 -O2 .load. And so now you will know which particular row your load file pertains to. And so, as I mentioned, the .load file provides the very important aerodynamic information which the aerodynamicist is looking for in terms of Mach number distributions or static pressure distributions on the airfoil to establish if this airfoil meets their particular requirements. And the output information that is available is tabulated here. So you can see, first of all, of course, the key information is the surface distance along the airfoil, the static pressure, the static to total pressure, this parameter that's often used by turbine people. For incompressible flow, CP, Mach number, isentropic Mach number, that's used by both compressor, turbine people. And then wall temperatures, adiabatic wall temperatures, skin friction, Stanton number, heat transfer coefficient, Y plus for the first node point from the surface. And this is important to make sure, especially for heat transfer calculation, to make sure that your mesh is close enough to the wall. So the first Y plus points should be certainly in the sublayer, and I'll touch upon this a little bit in more detail later. And the heat flux at the wall surface. So clearly this file allows the user to make some very detailed plots and calculations of the loading and other information on an airfoil. And so each airfoil defining section that's been defined in the input, there will be an output file that has all these parameters for that section. And so here, as way of example, this is for the vane, okay, at 50% span, and there happen to be a defining section, so it's for that defining section. And here is plotted the Mach number versus axial distance, okay, for both the suction surface and the pressure surface. This is actually a screenshot of an output file, and it shows that the .load file also provides up front this summary table which I discussed earlier under the mixed average file. So that's given again here, allows the user to check his input. And then below that is the first 3 input points for the load distribution. And that's a long table, so it's been cut off because typically that table will be 100 points or so. So it's a relatively long file.